This UCSD TV program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest programs. Also, make sure to check out and subscribe to our YouTube original channel, UCTV Prime, available only on YouTube.
Well, thank you for joining us for this evening's Exploring Ethics program here at the Reuben H. Fleet Science Center. I'm Mike Kalichman. I'm a director of the Research Ethics program at UC San Diego, as well as Center for Ethics in Science and Technology for the San Diego community. And that's the center that's working here with the Fleet Science Center. The Ethics Center has as a goal not only to talk to the public. The goal here is not just for you to hear and listen to people talk to you, but to give you an answer to ask questions as well as to provide feedback, ideas, perspectives, because the goal here is to look at the ethical issues and find the best possible solutions. Those are not going to come just from the scientists and the academics. It needs to be a collective effort of all of us. This evening's program is the fourth of 6 programs in the series. This series on the book Silent Spring began in October and has been co-sponsored. It's a collaboration involving multiple institutions around San Diego: California State University San Marcos, Grossmont College, Point Loma Nazarene University, University of San Diego, UC San Diego, and San Diego State University is not only one of those groups, but also the one that is specifically sponsoring this evening's program. To welcome you on behalf of San Diego State University, we have Alan Sweedler, who's professor of physics at San Diego State, as well as director of environmental sciences and the Center for Energy Studies. He'll introduce this evening's speaker and also serve as moderator tonight. So, Alan.
Thank you very much, Mike. Well, good evening, everyone. This is going to be a real fun evening. We're going to have a good time because Stanley and I'll tell you about, we're going to talk to each other and we're going to maybe argue, which might be interesting. And then we want you to join in that conversation. So we really want this to be an interactive event, and we want you to share with us your ideas and perspectives and questions, etc. Now, what we'll be talking about is a very interesting topic. I don't know if it's a fun topic, but we'll have a fun evening. And there it is there. We're going to talk about climate change and emerging infectious disease. Now, many of you have been probably inundated by information about climate change, but I have a feeling you probably have not quite either recognized or seen as much material about some of the health impacts on climate change, because that's, although specialists have discussed that, it's starting to work its way into the press, the popular literature, and of course the policymakers. So that will be the emphasis tonight, but we'll also talk about climate change in general. So we have a sort of 2 sides to the issue, or various sides, and we're hoping that you will help us bring this all together. Now, one of the reasons that I'm so pleased to be able to moderate and to participate is that I've come to know and work closely with my good friend Stanley Maloy, and one of the things I'll say about him, and also a little bit about why we're doing this. I'm a physicist, as you just heard. Stanley is a microbiologist. Usually those people don't talk to each other very much. And they just come from different worlds. In fact, in many places you've heard of the natural sciences and the biological sciences, these artificial boundaries. But one of the things that scientists do is they try to go outside of their field. They want to learn other things. They get tired of what they had to do for their doctoral dissertations, a tiny little thing. And one of the advantages of being in a university is that if you're so inclined, you can really do that. In my own case, I was trained as a low-temperature physicist, but I became very interested in environment and energy, and that's my particular specialty now. In Stanley's case, I mentioned Stanley's a professor of microbiology. He has become really interested in climate change and all of the environmental implications related to his core field of microbiology. So you can share with us our conversation, and you'll be able to participate in that. Stanley is also the Dean of the College of Sciences, which means he has to make a lot of ugly decisions and could make a lot of personnel decisions, which are always difficult but are always necessary. But because of that position, he's also able to see a lot of things going on in the broad areas of science. Stanley has also been the president of the American Microbiology Association. This is the main national organization, well, I'm sure it's international as well, that brings together microbiologists. So he's worked in these fields very deeply. He's very active in science, even though he's an administrator, which is not an easy task, as I can attest to myself to do. But it's a very important task. So we're going to start the evening that he will give a short presentation, and then we're going to come up to the stage, and we're going to have a conversation. And I'll try to help moderate the conversation and participate in it as much as possible. So let's begin and welcome Stanley Maloy.
Thanks very much, Al. It's great to be here. This is a really interesting opportunity to talk about how these different scientific fields come together. And so tonight, if you have questions about infectious disease, I'm your guy. If you have a question about the physical aspects about climate change, then Al's your guy. So we've got you on both fronts. This all gets down, though, to Silent Spring, right? So Rachel Carson wrote Silent Spring, and she focused on ways that humans disrupt the environment, and it has a long-term negative consequence on the world. Right? Use of DDT was one of the primary things that really stood up to the general public as an impact that became clear from this book. So climate change is not so different. It's a way that we disrupt the environment, have a long-term impact on the environment, and that long-term impact comes back and in many ways influences our lives and the lives of many people to come down the road. One of the things that Rachel Carson said in her book, she said, people use more gender-neutral terms now, but she said, man is a part of nature. So when man declares war on nature, man is declaring war on himself. And I think that that really reflects a general theme of disruption of the environment. So we're going to talk about global climate change and emerging infectious disease. And the question is, why did these things come together? And why do we think they're so important to talk about? This is a curve showing you the terrestrial temperature, the land temperature, from 1880 on up to 2000. And you notice a couple things from this curve. First, there's a lot of variation in that, right? On an annual basis, every decade, there's a fair amount of variation. But you can also see, when you look at this, especially since 1960, that this curve is rising dramatically. And through a lot of mathematical studies, we can show that that is statistically significant. And the increase in the terrestrial temperature is greater and more rapid than we have ever seen before in measurements from temperature changes on Earth. Okay? Now, there's something else that's really striking about this, though. Let's take a look at this axis, the y-axis. What do you notice about that? That's a decimal point, right? Look at those numbers. These are not Huge numbers. These are pretty small numbers. So why are we so worried if we're talking about a 1 degree change in temperature? What's the big deal, right? So let's go on. This is the ocean surface temperature. This plotted over that same time frame starting in 1880. And again, there's a lot of variation, but you can see starting around 1960, it's increased. That bar at the top represents an average temperature. You can see that we're now going substantially above that average temperature. Again, in the ocean surface temperature, we're talking about something like a 1 degree change in temperature. Okay? Now, does a 1 degree change mean anything? In fact, we'll show you that there are real-time impacts of that 1 degree change. For example, increase in terrestrial temperature changes the distribution of vectors, mosquitoes that can carry malaria, other insects that can carry Chagas disease, ticks that can carry Lyme disease. The increase in ocean temperature can enhance the growth of pathogens that live in the ocean. One has this big long name, Vibrio parahemolyticus, but it basically causes a very serious gastrointestinal disease that you get from eating raw oysters. And another is something we all know about, cholera. And then there are changes in the water cycle. This is when we have all of these big nasty storms that seem to arise associated with global warming. They can cause flooding and drought, and that increases waterborne pathogens like salmonella and rotavirus, and it also changes the presence of rodent vectors. And hantavirus is a great example of that. All right, so let's quickly go through a couple of examples. This is the life cycle of a mosquito. It has to have some part of its life cycle right under the surface of the water. Another part of its life cycle is on land. This life cycle is very, very sensitive to temperature. Each different kind of mosquito has a minimum temperature at which it can reproduce and in which it feeds readily, so in which it bites people. In addition, when the mosquito is infected with a parasite, the temperature at which that parasite develops influences the length of time required for it to get to a stage where it can cause disease. So in this curve right here, if you can see those two little red arrows, that represents a 1 degree difference in temperature and the growth of the parasite that causes malaria within the mosquito. Right? So look at what's happening here. You're going, by changing that 1 degree, you're changing the time it takes for the parasite to develop from around 17 days to up to around 25 days. When you think about what that means to the population of mosquitoes that can transmit disease, it's very impressive. The prediction is that that 1 degree change, or up to a 2 degree change, will increase the number of humans that are subject to malaria by something on the order of about 15% of the human population. Okay? 1 degree change, a dramatic difference in disease transmission. This is a prediction. What I showed you there was real data, but this is a prediction, modeling, of what that means relative to the changes in the spread of malaria. And all of these regions in red predicted by 2050 to be hot zones for malaria. Now, pay attention to this little part at the bottom here of North America. That's the United States, and that includes the region that we live in right now. Now, I'll show you one other one that has nothing to do with mosquitoes. It just has to do with life of a pathogen in the water. And this is this pathogen I mentioned, Vibrio parahemolyticus. Okay? Now, Vibrio parahemolyticus is in waters all around the earth. And if there's a shellfish, like an oyster, they get accumulated in the filters of the oyster. So if you have your nice raw oyster, you have a chance of getting infected. But this organism can't grow below 15 degrees. So although people get sick in New Orleans, and they get sick other places in Maryland, other places where we eat raw oysters, In Alaska, people never got sick. There had never been a reported case for many, many years. And the reason is the water temperature is below 15 degrees. This pathogen can't grow well. The very first outbreak in Alaska in raw oysters was 2004. Roughly a 1 degree increase in water temperature allows the pathogen to grow, now causes an infectious disease that did not exist to affect humans. Since that time, outbreaks are occurring on an annual basis in Alaska. Here's one more example. Cholera is a really serious disease that can cause pandemics that affect people all around the world. Cholera is this little bacterium that lives in the water. It gets attached to phytoplankton and zooplankton. When humans drink the water with that plankton, it can infect us, take up shop in our intestine, and cause a very serious diarrhea. When I say very serious, this isn't salmonella, folks. You see that guy sitting there? You see all those water bottles? That was the amount of fluid he lost during the course of infection. This is pretty typical. This disease kills people because you lose water. Your blood gets so thick you can't pump your blood, and you just die because your heart can't pump anymore. Right? This is what they put you in. If you're sick, they put you in a cholera cot, and they just measure the amount of fluid that comes out of one end, and they make sure the other end gets an equal amount of fluid. That's all you have to do to cure this disease. But the important thing is that this diarrhea in many parts of the world gets right back into the water, causing this really serious cycle. Now, that cycle is influenced profoundly by the temperature of the water. So if you look at these two curves, the dotted line is the sea surface temperature, and the solid line is the incidence of cholera. This is in the Bay of Bengal, which is one of the places cholera is endemic. An important thing here to note is that when the sea surface temperature goes up a little bit, that's the numbers on the right-hand side as you're looking at this, a 1 degree increase in the temperature of the sea surface increases the number of humans who get cholera by about 5%. That's a pretty dramatic change for a 1 degree difference in temperature. Now there's one other part of this that's really important. A 1 degree change in the temperature of the ocean influences the water cycle. The idea is the temperature influences evaporation. Evaporation puts moisture in the clouds. They move to the land. Precipitation gives rain and snow. Runoff returns the water with a lot of other nasty substances from land back to the ocean. The higher the temperature, the more this cycle occurs, the more rapidly it occurs. So we get more of these storms and then periods in between where you have drought. So you get these drought flood cycles. In parts of the world, people don't really understand this, but right here in San Diego, we all know about El Nino and La Nina and what that means for our particular climate patterns. So we're pretty used to that. So both these two things, drought and flooding, influence our water supplies. Right? Actually, it makes sense why flooding would be a problem, right? Flooding would wash things into the water supply. So why would drought increase? Why would drought increase this process?
It gets more concentrated.
The water gets more. The water doesn't get more concentrated. There's less water for everyone to choose from. But the other thing is, when water is in real short supply, people quit personal hygiene. So hand washing goes way down in periods of drought. So that's another source of contamination. So also we have increased rainfall. That provides breeding grounds for mosquitoes, one of the important disease vectors. And the heavy rain influences rodent populations. Okay? A great example of this is something called the Four Corners disease. So Four Corners is a part of the United States on the border between Utah, Arizona, and Colorado and New Mexico. Right up in that area, mainly Native American populations live in that Four Corners region. This occurred first in 1993 after a period of very intense drought. During intense drought, the food supplies for rodents like mice decreases, and the population density of mice goes way down, associated with low nutrient levels. That spring of that year, they had very heavy rains, and the rains increased the amount of seeds and plant foliage that the mice can eat. The population density of the mouse just exploded. When that happened, those mice, instead of staying out in the field where they belong, moved into the houses of the Native Americans. And the mice carry a particular virus. That virus, it was originally called sin nombre because we didn't know what it was. We now know it's a virus called hantavirus. And when the mice get in the house and they pee on the floor, somebody sweeps that up, the aerosol gets in our lungs and causes a very serious disease with a high probability of death. Okay. Now, this process is associated with drought, flood. When we see outbreaks of these diseases, and we now recognize them around the world, it's associated with these changes of drought, flood, and the concurrent changes in the rodent populations. Okay. I gave you a few examples. There are lots of other examples. Lyme disease is one. Diseases caused by aerosols can be influenced by the amount of moisture and the temperature of the air. For example, tuberculosis and influenza. Diseases transmitted by animals, another important problem. And in addition, diseases that are caused by toxins, like the phytoplankton making red tide toxin and aflatoxins that are made by fungi. So there's lots and lots of examples of this where this 1 degree change can have a big influence on disease propagation. All right. We're not here for a lecture in microbiology. We're here to talk about ethics. So the question is, what are the ethical implications of this? And here are two statements from people who have thought about and written extensively about the ethics of climate change. I think the basic fundamental point is that people are really concerned that a decision that we make right now, right here, based upon our standard of living, based upon our particular concerns about our own welfare, don't only affect us, they affect people all over the world. And not only people all over the world, but people for many generations to come. So with that introduction, I'd like to shift so that now we can begin our discussion and talk about these issues. Issues can be related to infectious disease, associated with climate change, to causes of climate change, potential solutions, and I hope ethics will be a real important part of our discussion today. Thanks.
So, first of all, thank you very much, Stanley, for that excellent overview. And as I mentioned in the introduction, perhaps a set of facts, observations that are not generally discussed in terms of climate change. And we can also discuss between us those issues. I'll raise a few issues about climate change itself and about the health impacts. And then, of course, we're trying to relate this whole thing to the 50th anniversary of the publication of Silent Spring, which is the theme of this series. And it might not appear obvious to some of you that there are some connections between them. And let me make one and then get Stanley's reaction to that. For those of you who've read Silent Spring, which, and if you haven't, I urge you to, it's a beautiful book. It's very well written and very insightful. You recall, of course, that Rachel Carson, who was a scientist, she was a government scientist, she worked for the USGS, and she was also a very popular nature writer. So she was well known when she wrote Silent Spring. And one of the main messages in that book, and what she devoted much time to, was the effect of using pesticides, particularly DDT, on the, you may recall, the thickness of shells of certain birds, and then that, of course, led to the bird population decreasing. The title of the book, I don't know if Stanley alluded to it, but it comes from a poem by John Keats, La Dame sans Merci, where in the first paragraph of that poem, Keats talks about a lake that's drying up and a silent spring with no birds. And that's what she was greatly concerned about. Now, how do we make the connection between that and climate change and global warming? Well, I think there is one. Because in the case of the pesticides, after all, they were being used for a good purpose. And I'm sure many of you, I remember being sprayed with that stuff. I can almost still smell it. I was one of those people in the swimming pools there. And just a few years ago, I was in India at a hotel, and suddenly a truck came by, and this white stuff started to come in through the doorway of the lobby, and it was DDT, because it's still used in many areas of the world for the same purpose it was originally used, to keep the malaria, which is very, very serious. But there are all these unintended consequences that occurred that Rachel Carson put out. So in a sense, what we have is doing something that looks like it could be good, but not really understanding it, and then having very serious consequences. And you can make a similar case for global warming and climate change. Global warming is a result of climate change. That we have been benefiting significantly for the past 100 years from the use primarily of fossil fuels and an economy based on those fuels, which has created great wealth in the Western world. Without coal, without oil, without gas, our standard of living would be much lower than it has been. And it has brought significant benefits. But at the same time, it's created enormous difficulties. One of them being air pollution, which is primarily traced to the burning of fuels. And another one, more recently understood, is the effect on the atmosphere as a whole, changing the climate. So you have a situation where something that was used for good, in the case of DDT to prevent malaria, had the effect of damaging a bird population and potentially others. Today we have the analogous situation up to a point where the burning and the use of carbon-based fuels has created significant air pollution issues, which is a very serious health impact from those who suffer from breathing issues and everyone else. But now it may affect the whole population of the whole Earth because of what we're putting up into the atmosphere, which in a sense is the analogous situation of putting pesticides into the soil. And this raises, I would think, extremely complicated ethical issues and moral issues as well. Who decides what goes into the atmosphere? How is it decided? Who wins? Who loses? Who gains? Who doesn't? Where are these decisions made? Are they even made at all? Are they just sort of the result of sort of continuing development of certain sorts? Do we have a right in the so-called developed world, North America, Europe, to deny the use of coal, which has given us great wealth, to China, to India? Should we even take a stand about that? And so deep inside the science, which is very interesting and very important, and we certainly can talk about that, of climate change, you have these embedded moral issues, ethical issues. And they're not very different from what Rachel Carson spoke about 50 years ago. And so that brings us full circle to the theme of this whole series. So that's a little bit, and maybe Stanley, you'd like to comment on that.
Actually, what I'd like to do is encourage some of you to come make some comments or ask some questions so we can stimulate the conversation. So if you have anything, please go to the microphone and let's talk together. While we're waiting, how many of you have read Silent Spring? When I was a kid, I think it was required reading in schools, so it was very widespread.
Did you want to introduce yourself as well? If you'd like, it's up to you.
Fine. My name's Arnold Gass. I've commented here before. So I think the first question that has to be addressed is what is the reality of global warming? I think before you can decide who suffers or who doesn't suffer, who's going to do what, whether there's an abdication of responsibility, we have to decide, do we actually have a problem? So science starts with description of facts. You've described the facts, you showed wonderful graphs, but there seems to be no general agreement. There's considerable political infighting in this country alone, let alone across the world. So how would you deal with the first issue, which is to describe and get agreement that we actually have a problem?
Well, that is a good question, and it certainly is the appropriate first question that we start at the beginning. Maybe I can use myself as an example. As I said, I'm not trained as a climate scientist. I was not brought up being inculcated that climate is changing, etc. I became interested in it because I'm interested in energy, and I'm interested in the environment and the effect on the human population. So I've had to educate myself to come to any particular conclusions. If you asked me that question, I'd say 10 years ago, I probably would have put myself into the real climate skeptic, or even climate, I wouldn't say denier. One should always be skeptical, particularly in science. One shouldn't deny if you're presented with real evidence. And my skepticism grew out of the modeling. I know enough about mathematics and physics and computers to know that you can get a model to produce anything you want, you know, garbage in, garbage out type stuff. Because at that time, 10 years ago or more, the data were not available. There was huge error in the data. There was a big discussion in the atmospheric science community, etc. Now, since that time, an enormous amount of research has been done, and that's what science should do. A huge amount of information has been accumulated. Satellites, buoys placed in ocean, land temperature gauges, taking into account heat island effects, taking into account all kinds of fluctuations, standardization of measurements, enormous increases in computing power. And every single serious study that I've ever seen in the past 5 years unambiguously shows that the average temperature of the Earth is increasing. Now, that doesn't say why it's increasing, so let's start with the facts. There is no discussion of any merit in the scientific community that the Earth is getting warmer. The discussion has been what's causing it, and that's something we could go into. And I think maybe one of the best examples of that, maybe some of you heard of Professor Mueller at Berkeley, who wrote a book called Physics for Presidents. He's a professor of physics. He didn't believe a lot of this stuff, and he wrote prominent editorials. He got funding to do a study from the Koch Foundation, who is not the most friendly towards the whole concept of climate change. But he went about it in a very systematic way. He organized a research program and looked at all the data. And last year he came out with his results. He says, I am no longer a global warming specter. He published it in the Wall Street Journal. He published it online. It's published in peer-reviewed journals because he convinced himself that the data were real. And so I would say that's my take on it. The data is there from all kinds of different angles, and they all point to an increasing average global temperature and a rate of increase which has never been seen before. So one can argue about the causes, but you can't argue, at least if you want to be in any way reasonable, that the globe, the Earth, is warming.
Hi, my name is Rita Lim, president of Worm Free World Research Institute. Thank you very much for putting this very important forum on. The nonprofit for which I volunteer is concerned about the 1 to 2 billion people in the world who are infected with intestinal parasitic worms. In my reading around the regions that are affected and the issues that concern them, which are really around the Millennium Development Goals, I see a very strange correlation between the lack of sanitation and intestinal parasites. 2.5 billion people don't have adequate sanitation. So what I'm trying to get to is that we need to take a very global view of what is happening, and that the consequences of either overaction or neglect or even attitudes have very significant effects on these people. We've been basically neglecting, just as we neglect a part of our society, those who remain unseen under bridges and so forth, we neglect a portion of the world who are hugely impacted by drought. And I see climate change as being a major factor in holding back our progress towards achieving the Millennium Development Goals.
So I think that that's a very important point. Schistosomiasis is one of these diseases that is influenced by a 1 degree change in temperature and the amount of propagation of that worm that can cause serious problems with humans. You can control a lot of these problems by clean water, right? So people say, okay, just clean up the water. What happens in San Diego when there's a big rain, right? This is San Diego. We're a developed country. We have great sanitation system. Our sewage rushes out to the ocean where people are exposed. So when you think about the difficulty of dealing with these extra issues in addition to providing clean water, it's a big problem worldwide. One of the other things that I think ties into what you're saying is how people in some of these other places feel relative to the way people here might feel about the issues of climate change. And Al and I taught a course last summer in Xiamen, China. And so it was very interesting because we had a chance to talk to students about their feelings about climate change and what it means relative to the first world attitude, if you will. Why don't you say something about that, Hal?
It was a very enlightening experience because, not surprisingly, they had a somewhat different view because they saw it, as many people in the areas of the world you're talking about, as a policy to hold back their development. And they're not wrong about that entirely. And we spoke about that in China, and I happened to be in India the year before that, and I gave a talk on climate change. And of course, one of the first questions was, who are you to come here and tell us what to do about using coal? Because of the reasons I said before. And in China, the students knew the issues, but they couldn't see a solution. In India, these weren't students, these were engineers and other scientists. They were more concerned about development and how that would impact their economy. And one of the things that we pointed out in the course, in both India and China, air pollution is a really serious issue. And they know it. And the message I gave to them was, you're right. How can I possibly say anything to you about your development? but you and your people breathe the air. And you are going to suffer much more from things that would reduce the air pollution and at the same time reduce the long-term impacts of climate change. In China, that is taken very seriously. You know, China is the leading developer of renewable energy in the world. It's true, they use a huge amount of coal. In fact, they use as much coal as the rest of the world combined. But they also produce the most amount of renewable energy. So China is, you can never say anything simple about China. There's always a this or another side to it. So we have one perspective in this country to a large extent, and we have to understand the perspective of others, because this truly is a global issue with local ramifications. Let's see if we can maybe give someone else a chance. Okay, thank you. Any other comments or questions? Would you go to the microphone, please, so we all can share your perspective?
Fred Walker, citizen. I'm interested in whether you think this is a reversible situation, and if so, I'd be interested in your perspective on what it would take, the steps necessary to take. In my perspective, it's largely political, and it's one of those issues that's funding, and funding will not allow certain things to happen as they should, much like the gun control.
Well, should I take that? Okay. Let's start with the first part. Unlike, for example, ozone depletion, which we knew very clearly was related to chlorofluorocarbons, by reducing or eliminating them, in fact, the ozone has recovered. That's not going to work in climate change. The reason is that the greenhouse gases, particularly carbon dioxide, but not only carbon dioxide, but mainly that, they're very long-lived. They go up in the atmosphere, they stay there for decades, even longer, hundreds of years. And the more we put in, and we're putting in more and more all the time, we're not reducing the amount of greenhouse gases going into the atmosphere. In fact, if anything, it's increasing. The more difficult it will be to deal with the issue. So I would say realistically, it isn't reversible. And all we really can do is slow the rate of change, slow the increase that inevitably will occur. And at the same time, adapt to it by doing certain things that we can talk about. That's called adaptation. And then also to attempt to reduce the causes that we pretty much know. We don't have anyone to blame but ourselves. We know what's going on. This is not a mystery. This is not a scientific puzzle or looking for the Higgs or something like that. We know precisely, exactly. It's 19th century fluid dynamics physics of what's happening in the atmosphere. We can't predict precisely, but you can never do that. But we have a very good handle. So we know what needs to be done to slow the rate. And I think that's probably the most that one could expect from this. But that's very significant, because the difference between a 2-degree increase and a 4-degree increase, which is if we do nothing, or a 5 or 10-degree increase, is really the difference between managing something and a world that we have no experience with at all.
I might add, there are many people out there who are trying to devise great schemes to suck up all the carbon dioxide in the air and to deal with some of these problems. Some of them may work. Some of them are things that, in fact, would have secondary consequences that, again, could be just as bad. Bringing more CO2 into the ocean, causing the acidity of the ocean to get worse. And so that's the amazing thing about ecology, and that's what Rachel Carson pointed out, was very often when you change one thing, there will be a secondary effect that you really can't predict until you see the aftermath.
If I can add, this is really a perfect time to bring in the ethics. This thing that Stanley's talking about is called geoengineering, and that's probably what you were referring to. That's the title. It's becoming very fashionable. There are lots of articles. Some are quite interesting. very respectable people. And the idea is to take carbon dioxide out of the atmosphere, for instance, put up fine particles called aerosols in the upper atmosphere to reflect the sunlight, to reduce the actual energy input into the Earth system, to seed the ocean with iron to increase the uptake of carbon dioxide using ocean as more of a sink than it already is. Now, in a laboratory sense, they don't violate any basic laws of science or physics or chemistry, but is it ethical to do this? You're messing with the atmosphere of the whole globe or the ocean that everyone depends on. What gives a small group of people who think they know what they're doing, the right to even expose the rest of the world to this? What if they're wrong? What are the consequences then? So I sense what would happen. People tend to react when there's a crisis. If the crisis of global climate change becomes a real crisis, where you're having sea level rise, massive floods, droughts and everything, when civilization itself is being questioned, I'm sure we're going to see a huge cry for this. But we're not at that point yet. We don't have to wait, so we act in a crisis mode. By doing a whole variety of things in the next 10, 20, 30 years, we can avoid the crisis and still be able to manage the situation without resorting to things that potentially could affect the whole human population.
Edie Harmon, and I guess you could say I'm a patient advocate because I have 2 tick-borne illnesses from tick bites in California. One of the things I'd like to be sure that you mention in the future is the role of migratory birds in spreading vectors. And questions are, who gets treated, who doesn't get treated, and how do you educate the medical community to understand that their preconceived notions of infectious diseases may be totally wrong, because what they learned in the past about the presence of certain infectious diseases or vectors is no longer, really accurate. But I think it's critical here, and it's critical in other parts of the world, especially when you consider the role of migratory birds.
So this is a very good point. I mentioned rodents, but migratory birds can also carry a lot of diseases. And as the climate changes, their migration patterns change as well. I mean, we can see this with Canadian geese that are not flying all the way to their previous southern roosts. And it's a real problem for us, and it's a problem for physicians, because all of a sudden we're seeing diseases that in medical school they were told, we don't have this disease here. And so this is a situation where I hope that the medical community becomes more aware of these issues. I know there are a lot of efforts associated with the movement called One Health to encourage them to understand this. It's also very important, I would argue, I've argued in this forum before, nowadays with our ability to look up things ourselves, sometimes we have to be the one who goes into our physician and said, I think this might be the issue, and to be able to explain it to them. And so that's a very serious concern.
Thank you.
I'm usually the doomsayer here. Perhaps what we need in the education system is something that maybe a few of us have experienced. When you have a small aquarium and you don't monitor it properly, it looks fine for a long, long time, and then all of a sudden it seems like the aquarium then turns foul, and the fish or the salamanders or whatever is in that aquarium die. And it is irreversible. You have to then clean the whole thing out, throw away everything, take it to the laundry sink and clean it all out. Well, unless you have a different God you believe in than I do, I don't know who's going to come down and grab our earth and take it somewhere and clean it out. Life will continue. It's just whether human beings are going to be part of that life that will continue. So the scary thing to me is that people are, as you said, perhaps becoming more aware as little changes or storms become more violent, or there's more flooding, or animals are going extinct, or honeybees are having difficulty, or not many people know here that salamanders and most amphibians are becoming extinct rapidly. And these are all warning signs, but when it does tip, it is going to be catastrophic.
It could be.
It could be.
I wouldn't deny that. And just let me comment that we have a lot of questions, so I'll just make it short. And if I could ask people to, if there is a question, that would be helpful too.
I do have one question.
No, you brought up some very good points. The
frustrated old teacher.
I understand that, all right. Much of human history has to do with migrations of human population, people moving from one continent, from one area, one region. When the population was very small, you could find other reasons to move into. We don't have that choice anymore in the modern world. We're 6 billion now. We're likely to be closer to 7. We're likely to be 9 billion by the mid-century. So in some ways, our ability to adapt to a changing climate, we have the technology, but the social structure, the infrastructure, the human condition doesn't allow half of Africa to move to a place where there's more water. So that's another issue that we have to learn how to deal with. And it's easy to be, by nature, I'm sort of a pessimist. On the other hand, there's a lot of positive information coming out in the world. Life expectancy is increasing. The quality of life for most people, not everyone, is really better than it was. You know, we don't have slavery officially anymore in this country or any other place in the world. And you know, growing up in the 50s and 60s, we had duck and cover, if you remember. The threat of nuclear war hung over our heads every single day. Well, it's still there, but it's not as bad as it was. So I would say human beings can progress. They have certainly the ability. What they lack is the organization, and they lack the skill in recognizing that a collective good is also an individual good. And that may or may not happen. We haven't been around very long, and we don't know how long we're going to last. So maybe we should go on that.
Well, I wanted to make one other question. One thing that does frustrate me is why don't scientists bring up the aspect of changing to a vegetarian diet worldwide, which will impact tremendously the amount of methane gas. We hear a lot about cars and engines and global warming because of those gases, but it is surprising, and I didn't come prepared with figures, but you can look them up, you know. It is surprising how grandiose the amount of global warming can be attributed to wide-scale factory farming for cattle and protein that we're burning our kidneys out and needing kidney dialysis and transplant because we're eating too much of protein, that if we modified the diet. So that would be an ethical consideration,
I want to
too.
make sure we have, because we have 3 other people at least. Thank you. I'm trying to look at the time.
Could you expand a little bit on your discussion of the Chinese students who understand the problem, that the problem exists, but seem to be extremely pessimistic on any sort of solution?
Okay, we both.
You know, it's a very interesting thing because the students that were in our class were students who are really trying to improve their lifestyle. They're thinking about the future, their own future, and the future of their country. And in the process of thinking about this, they really care about issues like pollution. You cannot be anywhere near Beijing and not know about air pollution. It's so severe there. But at the same time, they're really concerned that if they decrease their use of fossil fuels, for example, but the United States and Europe, other countries maintain these higher levels, they're going to still suffer. There's this real important ecological principle called the tragedy of the commons. And in the tragedy of the commons, Everyone's trying to get the maximum out of some little tiny resource. And by doing that, the whole community suffers, right? And so that's really their concern. They say, oh yeah, you want us to do this, sure, but you're not going to do it. And since we all share the same atmosphere, what good does it do us, right? We might as well burn the fossil fuel, have a little bit better lifestyle, better economy for a short period of time, and then we'll all go down together. But there's an old song, speaking of nuclear war, called "We'll All Go Together When We Go."
Yeah. but as I mentioned, saying something black or white about China, you're inevitably going to be wrong. It's just too big and complicated. At the same time they express that, or we know about the country, the leaders of the country, and partly because of many people pushing them, they recognize this as an unsustainable situation. And so they've put enormous resources into trying to reduce their use of coal. And the factories that are going in, the coal factories in China have the latest and most sophisticated air pollution. But that still doesn't prevent the problem. They're in a bind. They don't have oil. They don't have gas. They only have coal. We are in an incredibly good situation. We have all kinds of fuels for energy: oil, gas, solar, geothermal, nuclear, you name it. China and India, unfortunately, I think for the world and for them, they're only sitting on a bedrock of coal. So it's a real dilemma. Last question. Mike, how are we doing for time? Okay.
Great. Hi, I'm Valerie. I teach high school chemistry in Chula Vista.
Great.
So I'm trying to educate them. But my question is more about an immediate integration of all of this information into the larger community. I think most of us here are kind of on board with the whole climate change, turn off the light sort of thing. So my question really is, who is responsible to hold the media, journalists, and broadcasting companies responsible for sharing empowering, accurate information so that we can all get on board and not wait until there's a crisis where we're running out of water or people are dying of cholera in San Diego so we can avoid that? Who's responsible for that?
No one. Much of the media is irresponsible.
Journalism schools. But maybe I haven't done enough of a study of this, but I have noticed that in the climate change debate, you don't have on the one side and the other side. It doesn't seem like there are two sides anymore, which is always a bizarre thing in science. There are no sides in science. You have hypotheses and you validate them and test them. And it seems like journalists are getting somewhat more sophisticated. It depends who you read, of course. But you don't see the articles you did see 5-10 years ago when the whole thing was discussed: is there such a thing as climate change? Is there global warming? And I think that's because the data are now so unambiguous that the journalists, but we have to go into the journalism schools. Journalism, there used to be science writers, remember? They don't exist anymore, hardly. Well, people don't write anything for the newspapers. It's all other kind of media. But there are, you may have seen an article a few weeks ago in the LA Times about David Perlman. How many of you know who David Perlman is? He's 94 years old. He's the science writer for the San Francisco Chronicle. And I had the privilege of spending 6 months with him as a fellow at Stanford University when AIDS just began. He was the first popular science journalist to talk about AIDS and HIV. And he's still writing his science articles. Well, those people are gems because they take the time to learn the science and they try to educate other people about it. We need things like that more.
Okay. We should stop here. Thank you all very much.
Thank you all very much.